So this first problem, it asks us to draw a graph of a function that meets these criteria. The limit as x approaches 2 of f of x equals 0. F of x is not continuous at x equals 2. And f of x is continuous but not differentiable when x equals -3. And the limit as x approaches positive or negative infinity for f of x is equal to -1. Okay? So, we ask you to create a graph. And I'll provide you with a small little x-y-axis there. So, the key here is that you need to understand what all of these things mean. So when it says, so we can start by looking at the first two. The first two, they deal with the same point, x equals 2. So it says the limit as x approaches 2 of f of x is equal to 0. So what does that mean? What is happening at x equals 2? What does it mean for the limit as x approaches 2 to be equal to 0? What is f of x the same as? No, it's not about the what? The y axis to the y value. So it's saying the limit as x approaches 2 of y is equal to 0. So what's happening to the y values as x approaches 2? They're getting close to 0. Right? So we know that the y value is 0 is the x-axis. So we know that this function, as we approach x equals 2, right there, all right, we know that the y value is getting close to 0. And since it is the limit and not the right hand or left hand limit, we know that both the left hand limit and the right hand limit approach the y value of 0 x equals 2. Okay? Now, it also says f of x is not continuous at x equals 2. Alright? That means that there's what's at x equals 2? Probably a hole. Alright? And we know it's a hole because the limit does exist. So the limit's going, if the limit didn't exist, then you know it might be like a vertical asymptote or a jump with something. But since the limit exists, that tells us that the left hand limit and the right hand limit are the same. So we know right there is going to be a hole. Okay? Alright, so there's my hole right there, x equals 2 at 0. Okay. Now, we said that the limit is 0. So we know that there's going to be part of the graph coming off this way, part of the graph coming off that. We know there's going to be a hole there, and we know that this is going to be Alright? So, it says that f of x is continuous, but not differentiable when x is equal to -3. So out here, x equals -3, it's continuous, but it's not differentiable. So what type of things do we have where the graph is not differentiable but continuous? There's 3 types. No, jump. That would make it discontinuous. But there's 2 types
corner, cusp, and vertical tangent.
Corner, cusp, or vertical tangent. Okay. So over here at x equals -3, we know that there's going to be something where this function is going to have a corner or a cusp or a vertical tangent. All right. Go ahead and choose. I think it's probably easiest to draw a corner. All right. So let's put a corner right there. All right. We know there's going to be a corner. Now that corner might look a little bit different based on that graph. So at that point, the only other thing that we're given that must be true is that the limit as x approaches positive or negative infinity is equal to -1. So what does that tell us that there is that x equals negative, or y equals negative? The horizontal asymptote. So I know that there's a horizontal asymptote which will draw a red dotted line. Alright. So at this point we can kind of fill in our graph. Alright, and make a small change, right? So we're going to take that, it kind of goes like that. So it's going to go something like, I have something that goes here, and out like that. And then it goes here, up. And then something like that. If you have, so, and then you double check while you're stuck. Right? You ask yourself, does my limit at x equals 2, or does my limit as x approaches 2 of this function equal 0? Yes, it is approaching 0 that way. Is f of x not continuous at x equals 2? Definitely not continuous because there's a hole. Okay? F of x is continuous but not differentiable when x equals -3. Definitely continuous, but not differentiable because it's a corner. And do my limits of x approaches positive or negative infinity of f of x equals -1? Yes. That's how you create your graph. It's always good to double check. When you go through, you know, you have to check, 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 check. And the other thing that's important is make sure you're looking at it's comparing the same x value, it's talking about the same x value, those 2 points, those 2 bullet points probably go together. Questions about that? So what's the important thing? So in order for something to be continuous, what must be true about the function? The left hand and right hand limits must be the same, because that makes the limit exist. What must be true about the limit and the function value? The limit and the function value. What must be true here? The function value and the limit have to be the same number. Alright? In this case, the function value is not the same as the limit. Now, what about differentiable? What must be true about differentiable? Differentiable refers to, talk about something differentiable, and then you can take the derivative. So what do we know must be true about the left hand derivative and the right hand derivative? So they must be, the derivative of the function must be, the derivative must be equal to each other on the left hand and right hand side. Alright? That means that the slopes must be equal to each other. If you look at this is going to have a positive slope, this side is going to have a negative slope. Right? So therefore it's not going to be differential. Alright. So alright. So here it's asking to find all points for which the curve is non-differentiable. Briefly explain why. If it is due to discontinuity, state which type. Alright. So here it's in so we need to know it's going to be non-differentiable because it's a corner, cusp, or vertical tangent. And we know it's going to be discontinuous if you have anything where, you know, you might have a jump discontinuity or a infinite discontinuity in a vertical asymptote. Okay. So the first thing that we look at, the first equation says 1 over x squared minus 2. Alright? So we can see that this is we're going to have some issues why on this function.
think that why?
Why are we gonna have some issues here? I can't feel it.
And that goes with the number.
It does have something to do with the denominator. Well, in other words, there's something down there. If we have a denominator, worry about the denominator being equal to what? 0. Okay? So, we know that there's going to be some area where this function is not continuous. So, we have to, well, in this case, I'm not really going to factor this. But, what I'm going to do is I'm going to say, this is equal to x squared, or so x squared minus 2 is, when is this equal 0? And I add 2 to both sides. So I have x squared equals 2. How do I undo a exponent that's squared? I can do square root. So I get x is equal to plus or minus the square root of 2. Now we know that when a denominator is equal to 0, that this is going to cause a vertical asymptote. Alright? Therefore, this function is not continuous at x equals plus or minus the square root of 2, and that's because it is discontinuous. Alright? This is a vertical asymptote. Alright? And since it's not continuous, alright, and it is not differential. Now, these next two you kind of have to understand what the graph looks like. Alright, you have the absolute value of x minus 1. The absolute value function, and you guys know what that looks like? No, not those lines. Absolute value of x minus 1. Then the absolute value of x, the graph looks like. Absolutely sure. The absolute value of x, so if you just have y equals absolute value of x, it is going to look like that. Alright? The absolute value of x minus 1 is going to look like that, except it's going to be down. And you shift it to the right one. Like that. So, where is this? First of all, what does this have that makes it not differential? As a corner. The corner occurs at what x value? X equals 1. Right? That gives us a corner. We know that corners are not differential. Because if you look at this, the derivative if you want this way would be -1, the derivative if you want this way would be positive. Now you look at the cube root of x minus 2. And what we need to know there is what the graph of the cube root x will be like. Which you know what that looks like as well. That's going to look something like this. Alright. Now the cube root of x minus 2 is not going to look like that. It's going to be over 2 to the right. So where is this function be not differentiable? X is between 1.
So then this stuff have a graph.
Well, this isn't, is this discontinuous?
No.
So it's not discontinuous, which means it's not, that means it's not differentiable, but not because it's not because it's a jump discontinuity, a hole, or something, or anything discontinuity. How would you classify that? Look like one? Well, no, okay, that's not corner, it would look more smooth. It's a vertical tangent. Okay?
So the other question has many times that more correct.
These ones, yes, but it's typically, those are basic graphs that you shouldn't do. So the next function, or the next thing we're going to look at is, we're going to look at whether or not this piecewise function over here is divergent. Alright, so first we want to check to see if it's continuous. And remember, if something is continuous, the left hand and right hand limit are equal to the function now. Okay, so to check that it's continuous, first of all, we have to find out what g of 1 is equal to. Well, g of 1 is going to get plugged into this bottom function, because it says g of x is equal to 1 over x, or x is greater than or equal to 1. So we're going to have 1 divided by 1, which is equal to 1. Alright, so g of 1 is equal to 1. Now we need to figure out what the limit, left hand limit is equal to. The limit as x approaches 1 from the left of gx is going to be equal to g of x, if x is coming from the left, would be 2 minus 1, which is 1. The limit as x approaches 1 from the right of g of x is equal to 1 over 1, which is equal to 1. So this function is continuous. Alright, we check to see that it's continuous. But our other next question would be, is it differentiable at one? Because we know that there are things that are continuous that are not differentiable. So what must be true then to find out if it's differentiable is the derivative on the left must be equal to the derivative on the right. So we have to find the derivative of the left hand part of the function and the right hand part of the function. Okay? So we know how to find these derivatives. First thing we have is 2 minus x. So g prime of x would be equal to, well, let's clarify. G prime of x on the right would be equal to, so the right side would be which function? We said this function right here, 1 over x. So to take the derivative of that, right now, do we know how to take the derivative of 1 over x? What do we have to do to x? Half. Half is square root. Negative what? Negative 1. So it's going to be, we're going to have, that's equal to x to the negative first power. Alright, so what do? We have this negative 1, we bring it out front and multiply it, so negative 1 times 1, which is negative 1. X, and what do we do to the exponent? Subtract 1, so negative 1 minus 1 would be what? Negative 2. There's the derivative on the right hand side. Now, we have to look at the derivative on the left hand side. Okay? So, now we have 2 minus x. What is the derivative of 2? 0. What is the derivative of minus x? Negative x. We have minus x. That's to the first power, so we bring out this 1. So the negative 1, and then you have 1 minus 1 and 0, so x to the 0 power is 1. So you have negative 1 times 1, which is negative 1. So the left-hand derivative is negative 1. So I ask you then, are those two functions, are those two derivatives equal? They're not the same. So what does that tell us? Is this function differentiable there? No. Why not? The left derivative is not equal to right. Alright, so this would be not differentiable at x equals 0, whereas x equals 1. Alright? Not differentiable. Is it continuous? Yes. Okay? So questions about that. First thing you want to do, figure out if it's continuous, because if you can figure out if it's continuous, then it's one less. So that's the first thing you want to do. If it's not continuous, you know it's not differential. Alright? If it is continuous, then you need to check to see whether or not it's differential, whether or not the left and derivatives are equal. Makes sense. So this function is continuous everywhere, but then it's not differential. Next one says determine the constant A. Alright, so state points of this continuity where h of x is equal to 2 minus 2x divided by x cubed plus 3x squared minus 4x. Alright, so points of this continuity. We have what type of function here? It's a rational function. Because it has a denominator. Now, we know that points of discontinuity are going to occur when you have numbers or variables in the denominator, which we have, right? And if you have square root, if you don't have, you don't have to worry about that. So points of discontinuity are going to be where the denominator is equal to what? Yeah. So first thing I'm going to do, the first thing I would do here is obviously there's going to be something that I can factor. Alright? So let's just start by looking at the top. If I'm looking at the top of the sort of denominator or the numerator, can I factor anything out of the numerator? 2. So if I factor 2 out, I factor 2 and I'm going to have 1 minus x. Right? Is there anything I can factor out of all three terms in the denominator? X. If I do that, I'm going to have x squared plus 3x minus 4. Okay. Now, there's something else I can factor out of the numerator right now to make this 1 minus x look a little bit more friendly. Minus x. I don't want a minus x. I want a positive x. Because I know down here I'm going to factor something with a positive x. So what I'm going to say is, well, I'm going to take a negative sign out of both these. If I take a negative sign, if I take a negative 1 out of 1, I'm going to have negative 1. If I take a negative 1 out of negative x, I'm going to have positive x. So I'm going to just bring a negative sign out. Negative 2 times x plus 1. Okay. Well, here I've already factored 1x out. And then x squared plus 3x minus 4 is going to factor into x plus 4 times x minus 1. And I wrote this one. I should have x minus 1 top. Okay. So I see a couple places that I might have solutions. So I know my denominator is my denominator can't equal 0. Therefore, this x can't equal 0, this x plus 4 can't equal 0, this x minus 1 can't equal 0. Alright? So I know there's going to be a place where it's not continuous where x equals 0, a place where x plus 4 equals 0, and a place where x minus 1 equals 0. Okay? This one, I'm already done. It's not continuous at x equals 0. There's no extra work right now. Alright? This one, I need to subtract the 4 from both sides. And I get x is equal to negative 4. It's not continuous though. Over here, I have to add a 1 to both sides. Not continuous. Now, we also want to be able to state what types of discontinuities there are. Okay? What type of discontinuities are these 2 points going to be? X equals 0 and x equals 4. You make the denominator equal 0, but nothing else. Not a whole. Wholes make the numerator and denominator equal 0. Huh? Nope.
What was the last one?
Into the D. Vertical asymptote. So these two are vertical asymptotes. This one, x equals 1, x equals 1 makes the denominator 0 and the numerator 0. That's when you have a whole. Alright? Questions about that? Do I have to go over number 7?
Yeah.
Yeah, what are you going to do for number 7?
Well, which one is looking at? The egg, which one? You can do so.
All you want to do is show they're continuous. Alright? Now, these are nice functions that don't have anything to say that has make no contact where you have denominators in them. Okay? So if you just find them, so what you have to do in order for them to be continuous, first of all, you have to know the function value you use, right? You can't do that until you're on table.
So what was that?
Well, think about this. If they're going to be continuous, that means that the left hand limit has to equal the right hand, right? So you're just going to set, so you're going to just show that this is equal to this, and x is 2. So you plug 2 into both of these. You have number over here equals number plus a. No. I want to get to this one that a little bit more. Now, these ones that you guys should be pretty good. Alright? In fact, I don't want to have to go over these all the way. We'll just talk about how to start them. Alright? So number 8, it says find the average rate of change of f of x equals x squared plus x over the interval 4 to 9. Alright? So when you hear average rate of change, first thing you should be thinking of is what? Slope. Yes. So when you hear find the average rate of change, all you're doing is finding the slope between 2 points. That's why it's an average, because it's not at one point, it's over a couple of points. So what is the formula thing? So I should be able to, you guys tell me what is the equation to find the slope?
Isn't that like we want to find them?
It is y2 minus y1, but how do we represent it?
It's there, like 2 minus y1
Okay.
equals.
You think the slope is at point y minus y1 equals anything this?
Oh, yeah, that one.
What's the equation for slope?
Like 2 minus y1
Or what?
x 2 minus.
Good. Now, we don't represent that like that in calculus. Look. No, that's derivatives. And to find a slope at a given, like one point, at an instantaneous point, right? So to find the slope at one point, you use the derivative. However, to find an aggregate change, you use this, but then we represent it this way. So, all you do, for f of b, you plug 9 into this function, f of a equals 4 is subtract it, and then divide by 9 minus 4. Alright? Questions about that? Now, this means what? Is VDS. What does that tell me to find? Now we're talking about the derivatives. Alright? Now, we have 9. So, who can tell me how to make it? We want to take the derivative of 9. We'll take the derivative of that. What's the first thing that we're going to want to do? I see there's an exponent right here. I don't want that exponent. Alright? So, the first thing I would do to make it easy for myself, I'm just now learning how to take the derivative. Is if I divide by 3, that same is multiplied by 1/3. So I know that, so this y value, so this function right here, is actually 1/3 x. So actually, what I'm trying to make the derivative of is d dx, what? That's 9. Of x divided by 3, that's the same as saying 1/3 x. I'm going to have 2 divided by 5x squared. That's the same as saying plus 2/5 x to the negative 2 plus 2x minus 1. Okay? So how would I take the derivative of this? Huh? Do like I usually do, which means I can do each piece individually, right? So, we're just go around the table starting with Michelle, then Shamara, then Akira, then we'll go back down. Michelle, what is the derivative of 1/3 x? 1/3. Shamara, what about right here? 2/5 x to the negative 2. You want to explain the process, we can help. Not 2 to 5, just 2/5 by negative 2. Okay, so 2/5 times negative 2 is just going to be negative 4/5. Minus 4/5. X. Good. Here, what about 2x? 2. And then Michelle up minus 1. Go away because it's a. Alright. You could leave it that way, except for the fact that 1/3 and 2 were combined, because they're both constants. 1/3 plus 2 is going to be 2 and 1/3, or x equals 6 thirds, so 7 thirds. I got 7 thirds because 2 is equal to 6 thirds. 1 third plus 6 thirds is 7. Good. Now what is number 10 asking us to do?
On the third derivative. Oh, no.
Third derivative. So how do I find the third derivative? Yep, gotta start from the first one. So, first v1, vx. You don't need to put that one. So the first derivative is going to be equal to what here?
2x minus 8 x to the third.
Good. More. What would be the second derivative? Yep. And Michelle? Third derivative? Good. Meet up. Good. Third derivative. How you guys feel about those types of derivatives are pretty easy, right? What about the idea of derivatives in general? No. Because if you can do this, you can do pretty much anything.
Yeah, not so much in the name.
Again, so I don't want to have to go over all this. So you don't have to write all of down what we have right there. So you can say write number 11, number 12, and number 13, not right out the top. Now, here's what I want to do. I want you guys to go home and practice this tonight. So I want to make sure you know how to start. Alright? Whenever you see the word rate of change, average, just rate of change, that automatically tells you that you're going to have to be using what? The derivative. You see that says when x is equal to 2. Alright? So, what I want to do, I want you guys to go home and do this. And saying, find the derivative of y equals 4th root of 1 over x minus 1 x equals 2. So all you have to do is find out what the derivative of this is. And then after you have the derivative, y by 2. Now, to help you guys make sure you can do this, just to get started, because eventually what's going to happen is you're going to know how to do this without having to manipulate everything. You have to rewrite this in terms of power that we know how to work with. Alright? So, we have a couple things here. We have this 4th root. What exponent is that? Square root is 1/2. Cube root is 1/3. 4th root is going to be 1/4. So, exponent that is, you have 1 over x minus 1 to 1/4. Okay? Now, with that, we start something in the denominator. We don't like that. Because right now, you guys don't know how to work with that. You will, not right now you don't. So, you have to take that x minus 1 and bring it up to the numerator, and you give it an exponent of 1.
Negative.
That's going to have an exponent of negative 1 less. Alright? So it's going to be, now it's going to be 1 times x minus 1 to the negative first power. 1 times it, and it goes itself. So it's going to be x minus 1 the negative third power, the fourth power. Okay? Or if you're there, that's going to be equal to x minus 1 to the negative 1 third power, and then you take the derivative. Okay? Yes. Now, these next problems, number 12 and 13, it says, for the curve y equals 2x cubed minus 4x plus 1, find the equation of the normal line to the point negative 1, 2. Find the equation of the line, we need two things. Right. Slope. And what else? And the point which you're given. So it gives you the point. How do you find the slope of it? How do you find the slope of a function at a given point? The derivative. So the slope equals the derivative at point. Okay? So find the slope of this point at x equals what? Negative 1, that's x equals y is 0, we don't care about 3. We would have to find the derivative of this function, 2x cubed minus 4x plus 1, then plug in negative 1. Find the derivative, that's going to give you the equation for the slope. And then you're looking at point negative 1, so you plug negative 1 in there. So that's going to take the slope. Alright? Now, we heard what normal means. Not tangent, what does normal mean? Nope. Perpendicular. So normal means perpendicular. Alright? What does the slope of a perpendicular line have in common to the tangent line? If the slope of the tangent line is 2/3, what would be the slope of the normal? Negative. Yeah. Is reciprocal. So perpendicular equals negative 1 over, and I'll put n because n is the slope. Alright? That makes sense? And then, Michelle, going back to what you guys needed, you're saying, so now to find the equation of the line, you use what? Y minus y1 equals to m times x minus x1. So you know your y value and your y1 and x1 are your point. And your the slope, and you can just plug those in and that's you're done. You can leave it. This is the equation of a normal line. Find the equation of the tangent line is the same thing, except x equals negative 3, so you find out what the y value is. So we can do this. So first of all, we can rewrite this as y equals x plus 1 to the 1/3. That makes it a little easier to find the derivative. And you're also going to have to get the y value by plugging x in. So y is equal to the cube root of negative 3 plus 1 is equal to the cube root of negative 2. The cube root of negative 2. Again, find the equation. Find the equation of the tangent line using slope. Slope is the derivative at the point. Find the derivative of that point in. tangent line is gonna be that slope. Okay, we're gonna do that. Down here, it says find the point, so point on the curve, y equals x plus 1 over x plus 1, so that's actually y equals x plus 1 to the negative first power, where the slope of the normal line is 4. Okay? So, if you want to know what the slope of the normal line is for, what does that mean the slope of the tangent? What is it? Not negative 4. Negative 1. Alright. So let's do this one right here together. So it says find the points on the curve where the slope of the normal line is 4. So tell us we need to know stuff about the slope of this function at a given point. So that tells us we need to find what? The derivative. So dy dx. What would the derivative be of x plus 1 to the negative first power? Alright, so I'm going to rewrite this now. It makes it easier to figure out. So it's negative 1 over x plus 1 squared. So what does the derivative represent? Slope of what? Represents slope as one. Represents the slope of what as a line? Tangent. Right? So this is the first derivative, and it represents slope of tangent line. Right? One of the points, the x values, when or where the slope is of the normal line is 4. Well, we said the slope of the tangent line would then be the normal line is 4, the slope of the tangent line would be what? Negative 1/4. So we know that the derivative negative 1 over x plus 1 squared will be equal to negative 1/4. Alright. Cross multiply, we're going to have negative x plus 1 squared is equal to negative 1 times 4 is negative 4. Okay. I'm canceling these negative signs out by dividing by negative 1 on both sides. That gives me x plus 1 squared is equal to 4. I'm going to take the square root on both sides. X plus 1 is equal to plus or minus 2. Okay. So what that tells me is that x plus 1 equals 2, or x plus 1 equals negative 2. Subtract 1 from both sides, and x equals 1. Subtract 1 from both sides, and x equals negative 3. So that tells me that at x equals 1 and at x equals negative 3, the slope of the normal line for that function is 4. At these few points, x equals 1, and x equals negative 3, the slope of the normal line of this function, y equals 1 over x plus 1 equals 4. Alright. Number 15, what do you need to do?
The second one.
Find the second derivative and then do what? One. You guys think you can do that with help? Going over it? Okay, let's rewrite that next real quick. After next, to rewrite it so you guys, it's easier for us to take the derivative to review what. X to the 1/2 plus 2x to the negative first minus 6. How many times you taking the derivative? Alright. No. Find the points on the curve. And x. With a tangent line horizontal. So what's the first thing we're going to do?
Find the derivative.
Okay, so find the derivative. Guys, this one's really important, like understanding what it means for horizontal tangents. What does that mean, the slope of that tangent line?
Horizontal.
0. Alright? So, you're going to set derivative on set f prime of x equal to 0. Alright? So, that's about it. And then you solve, obviously you solve that. Okay? So there may be some factoring involved. Okay? So first of all, 18, how do you get, like, do this intuitively? Right? Intuitively, you have to think about what it's asking. So it's saying, this is the way I do it. Because I can't use calculator. So the limit as x approaches 3 to the right. So, I can underline this 3.
Right next to it.
Yeah, so the number that's right next to this, but on this side, would be like 3.001. So I'm going to plug that number in. So it'll be 3 divided by 3.001 minus 6. That would be 3 divided by 0.001. That's going to end up being 3,000. That's obviously going towards what? Y value. Correct. Yep. Yep. So that's going towards 3,000, which is obviously going towards infinity. Right? And so, questions on that first one. Now, had this been from the left, it would have been like negative 0.001. Because I would have like 2.999 minus 3. Is bigger than that one. So that's negative. So that would be negative. Okay.
So we would plug in 2.999 or negative 0.
If it says limit as x approaches 3 from that, you'd choose like right here, which would be like 2.9999. So it would be 2.99 minus 3, which would be, so if you calculate that equal to negative 0.00. 3 divided by that would be negative 3,000. That's obviously. Alright. So here. Alright. That one would be cool, and we know that the limit would be equal to what if what was true? That's what. This one would be easy, and we already know that if this had what where. If there's a 1/3 in, we'd be good. There's not a 1/3. But can do some fancy multiplying by 1 and multiply by 1/3 on the top and 1/3 on the denominator. Okay? So that gives us then the limit as n approaches 0 of 1/3 sine 1/3 n divided by 1/3 n. Okay? Properties of limits allow us to do what with this 1/3 right here? Because it's a constant, right? So what this allows us to do is it allows us to take this 1/3, and we're going to pull it out here. So it's going to be 1/3 times the limit as n approaches 0 of sine of 1/3 n divided by 1/3 n. So sine of 1/3 n divided by 1/3 n as n approaches 0, that limit would be what? 1. So I have 1/3 times 1, which is equal to 22. Looks hard. However, not that hard. Okay? So it just takes a lot of thinking. Okay, so first things first. This piece over here, I'm going to deal with last. Okay, 'cause that's easy. So, look at this. We have the limit. Next equals 0. Now, here's what we can do. Since I have this expression plus this expression, what can I do with these two? Property of limits. What does it say? If I have f of x plus g of x, the limit of f of x plus g of x, I can do what? Regular. The limit of f of x plus the limit of g of x. So I'm going to do this. Just sort of break it up so it doesn't look so complicated. Okay? Yeah. Now, right here, I'm pretty sure that we can all see that. Okay. I probably want to use this little trick over here. I probably would like to say, like, I see sine of 2x. I'd like to see a 2x on the top. I see a sine of 3x. I'd probably like to see a 3x above it. Right? Yeah. I don't know if that's doing that. Right. So, can I get a 2x there? Can I multiply by something to get a 2x on the bottom? What? I could, if I do 2 over 2, that would just give me 2, that would give me 2x, but that would give me 2 over 2, that would give me a 2x on the bottom. Do I have any x's down here on the bottom besides this one that's involved in the side? So I need to get a whole 2x on the bottom. How do I do that? Multiply by what? Multiply by 2x over 2x. I'm going to multiply by 2x over, it's a big x. 2x over 2x. Now, cool. See this sine 3x? I would like to have the 3x up top. So what do I need to multiply by? And then 3x over Yes, all right, cool. Now I got everything I want. I'm gonna break this up really quite a bit, okay? So, I have, now what, okay, so let's think about this. What can I do with this 5 that's just sitting out here doing nothing?
Bring out the front.
I'm gonna bring that 5 out to me, okay? So, I'm gonna have 5 times the limit as x approaches 0. And I'm gonna have sine 2x. So, well, first of all, I'm gonna have 2x times 3x times sine 2x. Alright, divided by 2x times 3x times sine of 3x. Okay? Now, I have my sine of 2x over 2x. I have my sine of 3x over 3x. So I don't want to mess with this 2x and this 3x. Those help, right? But, well, I can't, yeah, I still have this one here. Plus the limit as x approaches 0. What do I know about something over here? Did anything cancel out over here? Excellent. So 1x and that x cancels out here. So I'm going to use this method x plus 1. Okay. So, what's going on? So I noticed this x cancels out with this x. Okay? And I'm now left with a constant that is 2, and a constant that is 3. Right? Maybe let's do this. Maybe right. It's 5, so this would be 5 times the limit as x approaches 0. Now, since this is all this is multiplication, I can rearrange stuff, I can move stuff around, and I can break it up however I want. So this is going to be sine, I have sine 2x over 2x. That's sine 2x over 2x. Times sine 3x over 3x. That's, just 3x over sine x. It means times 3x over sine 3x. Okay? Times. And then I still have this 3x, no, I don't. I still have this 2x and this 3x. So times 2x over 3x. So these x's cancel out. And what happens is, and so let's actually do this. So we have the limit as x approaches 0, so I can just plug 0 in here right now. So 0 plus 1, what's the limit? So the limit of x plus 1 is x approaches 0, is 0 plus 1, so that's equal to 1. So again, right here we have plus 1. Okay. Now, I have 5 times, do I have any more constants that I can now pull out? 2/3, right? Just 2/3, no extra. Pull it out, so it's times 2/3 times the limit as x approaches 0 of sine 2x over 2x. Do I know anything about sine? What do I know? Do I know anything about 3x? Do I know about sine 3x? Or, yeah. Kind of, but why? Because I can go, instead of multiplying by this, I can divide by sine 3x over 3x. Is multiplying by this is the same as dividing by the reciprocal. So then I have all that plus 1. Okay, we're done pretty much. 5 times 2/3 is what? 10/3. What's this limit right here? What's this limit right here? What's 1 divided by 1? 1. So 10/3 times 1 plus 1. times 1 is 10 thirds plus 1 is going to be 13 thirds. I think I was wrong. Maybe I think it's wrong. Oh, wait. You get 13 thirds. Alright. So there's a lot of work. But you can, but I showed all my work. Like, probably could have got away with shortcuts going on. But, then we'll do this. So you guys are going to do the rest of them. Alright. You guys, okay, let's look at 23. 24 should be pretty easy. It's just what it's asking you, which the following represents the slope of the curve. It's asking you about the derivative. So that's just what we did when we were finding the derivative, like with x plus h. Alright? Well, let's just talk about 23 real quick. It says a particle travels along a horizontal axis so that its position for t greater than or equal to 0 is given by s of t equals 4/3 t cubed minus 7t squared plus 6t minus 2. So that's the position function. So real quick, when it says find the average velocity of the particle from t equals 0 to t equals 1, what is the relationship between velocity and speed functions? I messed up. Yes. Velocity has a direction. Speed is just the absolute value of velocity. Other question I need to ask. What is the relationship between position and velocity? You definitely should have written down those.
No, we don't.
Definitely good. Yeah. In number 23, you're given the position curve, right?
Is that what the
S of t. S of t is position. V of t is velocity. So the velocity function, so whenever you're trying to figure anything out about velocity, you need to find the first derivative of the position. Alright? If you ever need to figure anything out about acceleration, you need to find the second derivative of the position. Alright, so maybe you can write that down. So you have S of t, S position. Okay. S prime of t is equal to v of t, which is velocity. And then S double prime of t is equal to v prime of t, is equal to a of t, is equal to acceleration. Okay. So, in your position function, you have the first derivative of your position function is your velocity function. The second derivative of your position function is the first derivative of your velocity function, which is your acceleration. So it asks you to find the average velocity of the particle function. Average velocity, average rate of change means f of v minus f of a over v minus a. If it asks you to find the velocity at...
Wait, that's for average velocity?
Yeah. Now, if it says find the speed of the particle at t equals 1, you know that speed is equal to the absolute value of velocity. So to find the speed at, in that case, t equals 1, you find the velocity, so you have to find the first derivative, find the velocity at t equals 1 and make out to value. And on part C, when it says at what time is the particle at rest? Particle at rest means that the velocity is equal to what? 0. So you set the velocity function equal to 0. So, for x. So, on the back page, where it says calculator entity required, the first three, you're just finding the derivative on the calculator, math 8. Right? The next four, you're finding the limits, and you're just looking at the graphs or tables. And then 9 and 10, it's just asking you to find, really it's just asking you to find the velocity stuff given the position, right? And you can do that, like, and we'll look at number 9 real quick together. We think we have enough time. We'll look at, like, 9A. So, 9A could either be really challenging for you, or you can make it really easy for yourself. It says, what is the velocity after 1.25 seconds? So it says, a projectile is shot upward from the surface of the earth with an initial velocity of 84 feet per second. The position function is modeled by S of t equals negative 16t squared plus 84t. What is the velocity after 1.25 seconds? Well, we just got done saying that the velocity is the what derivative of the position function?
S times t equals.
So velocity is the first derivative of, which is position function. So I do not take, because I want to find the first derivative of the position function. I'm given the position function. I want to find the first derivative at x equals, or in this case, t equals 1.25. So I put x. All right. Up here, I type in my position function. Negative 16x squared plus 84t. 84x doesn't matter. The x is the t representation. I want to figure out what so the first derivative of this is going to be my velocity. I'm going to have the velocity at 1.25 seconds. That's like 1.25. I hit enter. So my answer would be 44 feet per second.
That's the velocity.
Yep. Because we found the value of the first derivative. And it says I use my calculator, so I don't need to do it. I don't need to do it. Actually, I don't want you to do this. So if you do this problem on your own, go ahead and calculate it. And you make sure on your work. What I want you to do is I want you to get the habit of going for writing. So put on your paper ddx parentheses negative 16x squared plus 84x parentheses. And that little line x equals 1.25. That way I know what you like how you got that.
What am I saying there?
That's 44 what? And that says
Wait, which one was the one where you had like, I had like a inches, like cubes and inches?
see the inches? That is the volume exchange. That is the volume exchange. We'll do where we talk more about that. Now it says when is the projectile at rest? Well, what you would do is then you actually have to find out what the second derivative is. Alright, so the second derivative would be so this or not second, the first derivative of that would be what? Should mark with it. that problem. So what is the derivative of that position function? Yeah. The negative 32x plus 84. So to solve this, let's figure out when it's at rest. Easy way.
Can I just get Alexis Alexander and Del Rio Robinson to attendance, please? Alexis Alexander and Del Rio Robinson to attendance.
And 6, so I can see it. So you graph it. Alright, so you see that this is the velocity is equal to 0 right here. So I go second, trace, I want to find my 0, so I hit 2, and then I need to be to the left, so to the left of that would be 2, so take 2. To the right of that would be 3, take 3. 0, so it's 2.625, so that t equals 2.625 seconds. Then I'm done. 10:50 doesn't make much sense. 2.625. And that is that.